Hello, hello. Good morning or afternoon, wherever you are in the world. Today, I would like to talk about. I'd like to make a calculator. I'd like to show you how to make it like a little calculator. Now, there's a couple stipulations. Stipulations to our calculator. Doesn't add more than 10. um, so that's the case. But it gives you an idea on how to add numbers in the assembler. Okay, and also too, I want to apologize for. Let me take a detour and show you this. This is an XP running in a VM, and on the last tutorial, I showed you, or I was trying to show you how to read a file from the assembler. Now, this is a functionality I ran into, um, and I believe it to be only with the interrupts. That's the issue. Let me turn down my scientific videos. I'm watching Robert J. Oppenheimer. Super fantastic guy. Um, why am I going to talk about Oppenheimer right now? Because I got him blasted on my TV. Head physicist in the Los Alamos Project. Constructed the bomb. It's basically what it is a classic example of how science and human nature just clashes, and him and all the other great scientists made the atom bomb and were deeply disturbed afterwards about making it and using it on people. How science can definitely be perverted for the wrong things. So if anybody's ever so inclined to check that out, check it out. It's pretty cool. So let's say this. On my other tutorial, I was showing you how to read a file, write into a file, and then I tried to read from that file, but I had no luck. I had no joy with this. Oh, oh, fuck! I hate Windows. I hate Windows. Let's do this. Throw all down. Let's try not to make that loud beep happen again. fread.com. Okay, the same thing that we got with with their last tutorial on DOSBox. Hope you guys can see my pointer. But when I tried to read out a file, it just gave me back a string of zeros. And this works. The functionalities are. Let me exit this out. Let me open this up here. The functionalities are that with. Let me see. I'm using DOS 7.1 on my other machine, and it works over there. And it does not seem to work on DOS CMU, which uses a newer version of DOS. And on the XP machine that was just in my VM, it does not seem to work over there. So, like I told you before in previous tutorials, certain levels of Windows have been diminishing their DOS capabilities. And it seems that Windows XP is one of them that does not accept these either opcodes or this function to read from files. And I think it's more of an opcode issue, and it's not so much a functionality of the whole thing. But it could be a functionality of the whole DOS thing altogether. But you can experiment on your own time if you want to with the interrupts. Like I said, check out Ralph Brown's interrupt list. Okay, Google that. And I don't think it's Ralph. I think it's Ralph. Like this. Ralph Brown interrupt list, right? Google that and check that out. And you can use the same source code that I showed you in the tutorial. But on On an XP machine, this will not work. So if anybody's got XP and wants to try this these debug toots on an XP, it may not work. And on a DOS EMU, it's not going to work. But if you have something like Windows 95, which actually I don't know why anybody would, or maybe 98, maybe it would work on them. I don't have those two, but I do have a DOS Windows. I have a DOS 7.1, I think, which is from around like 95 version, so it works over here on mine. Okay, so I apologize for that, but experiment with the interrupts, and maybe you can get farther than I did with that. Okay, okay. So first, let's say this. Let's say dir calc. I'm gonna make I'm gonna say edit calc 2. Okay. Okay. Now I'm gonna try to build a basic calculator, and like I said, it only counts to 1 to 10, so it's not really that phenomenal, but it does show you how to add numbers and stuff like that. It's RC exit 300 bytes. Let's name it calc2.com, and we're gonna write and we're gonna say quit. Okay. That's all set up. So first thing we have to do, or we should do, is kind of say something here. Let's set up a display message. Okay. And then what we want to do is we naturally want to get, let's say get a number, or let's say get number 1. Okay. And then we have to get, say get number 2. Okay, and then we should either add, yes, this is going to be an adder, so we'll just say add numbers, and now we want to say something like 2. Okay, okay. Now, like I said, I like to do this sometimes to mark out exactly the direction I want to go into, so it doesn't look like I'm just typing in machine code. And for somebody who wants to learn this or do this, this may help you out with keeping track of where exactly you are. Now, how do we display a message in DOS? That's pretty easy. We first have to say move into AH, our string. Okay. Then we want to move into DX, the location of our string. We'll put that at 200. This string. Okay, that's going to be our message. Now, let's go down here. We're going to add our string down here. Let's say define bytes. Enter a number. Okay. Now let's say 24. That is our out string. 24 for a string. Blah blah blah. And int 21 is up here. Okay. Okay. Now, what we want to do is we want to now that we have that string's done, we don't really need to save anything from that string. We want to get number 1. So by that we'll say move into AH 01. 01 is get character, or is get character. Okay, get character and show character. All right, 01 is our opcode for that. That's kind of what we want to do. Okay, so let's get that. Now we want to int 21 that. So we get it, and to int 21 we execute that. Okay, can we say load it? Sure. It'll load it into our registers or all that stuff. Okay. So after we say int 21, let's then say we need to not only we need to get a number there, we also need to get another number. Now when we get these numbers, we need to use opcodes, and opcodes only go in the AH register. Okay, so when we get another number, we're going to have to use the same opcode in the same register, but there's something already there. Okay, so like in the other tutorial, I showed you about handlers and whatnot like that. We're just going to move this number that we already got in the AH register. We're going to move that into the CL register temporarily. Okay, so that our second number does not overwrite our first number we put in. Okay, then after that we want to say move into AH01 again, which is going to actually get our second number. Let me move this like this. Super. Okay, and we want to say move num1 away. Okay, and then we get number 2. Okay, and then what we can do is here we can now execute the above. Okay, now this is where the good stuff comes in. Our number that we get is going to have the number that we input, remember, is going to be in hexadecimal. Well, say if we put in 5, right, and then we put in 4, okay, these numbers are not going to come out as 5 and 4. Okay, the true values of these numbers are going to be 35 and 34. Okay, now if we were to dump them out right at 35 and 34, if we were to dump them out right away, we would come up with something like 69. Okay, and instead of converting that or using a table to convert that and everything else like that, we can convert it right from here. All right, and we'll say something like, we have one number occupied already. We have one number in the AL register, okay, and we have one number in the CL register, okay. Like I said, when we put this in the AH register, this 01 in the AH register, whatever number we put in is going to get moved into the AL register, okay. And it's sort of like a handler, but it sends a return value, okay. So that number gets moved into the AL register. So whatever we have in the AL, we're going to move into CL. But those are going to be in the ASCII form. They're going to be in the hexadecimal form. Okay, so let's do something like this. Let's say sub from the CL register 30. Okay, so whatever number is in here in the CL register, whatever our first number actually was, it's going to take 30 off of that number, and it's going to leave us only with the basic stripped down type number. Okay. Okay. So let's say strip hex value. Okay. And then we want to do the same thing with our AL register, which contains our other number. Okay. Okay, that just says whatever else was already there, or above, read the above line. So that strips off the hex values. Now in order to add these two together, we can actually do that right now. Add, let me say add what is in the CL register with what is in the AL register. Okay, so that combines the numbers. Combines nums. Okay. And the number that we get is going to be stripped down. Yes, it's true now. Okay, this is almost in our raw form, but we need to take it and put it in something that we can read on screen output. Okay, so say if our two numbers were 3 and 4, if 3 and 4 were in here, okay, of course naturally that equals 7 to us. Alright, but we need to make it so it prints out an ASCII value to the screen. 7 in ASCII is not the number 7. Okay, 7 in ASCII, you can look it up on the table, but it is not the number 7. Alright, so we need to make that so we print out the actual true number, which would be 7. Okay, so what we need to do is we need to add, we already moved our AL into the CL, so this contains our total of numbers here. Now into our CL register, let's add, let's actually go this way, go down. Into our CL, let's add the CL 30, okay? And that's going to pop it back up to ASCII value to print out to the screen. Makes ASCII So now we need to do that. And let's go ahead and we will say, let's execute this. Int 21, int 20. And we'll see how this works out for us. Oh, I don't want to exit it yet. I want to move some stuff around. I'm going to move this out of the way. Let's move this out of the way. This total, yeah, we could get rid of it, but I'm not going to get rid of it right now. And 20, okay? Control Alt, down arrow, exit, sure, yes, I do want to save it. And let's say debug calc 2 or calc 2.asm or not, dir. Okay. Debug calc 2.asm. How come I'm not getting no action? No action injection. Edit. Calc. Oh, calc.2. Debug calc dot 2 dot asm. Input from blah 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 blah. Okay. Now, so let's move it then. I'm getting problems with how I name my file. Move calc dot 2 dot asm. Do calc 2 dot asm. Dir. Okay, let's move calc 2 dot 2 to calc 2 dot okay, clear. That worked. So let's move calc 2 now. Calc 2 to calc 2 dot asm. Back command calc 2. Dir. Calc 2 is there. Okay. Let's move calc 2 to calc 2 dot asm. Dir. Okay. Let's see if we did that right. Edit calc 2 dot asm. Okay, that worked. Alright, that's a little pain in the butt. I'm gonna say debug calc 2 dot asm. Okay. Now I don't see any errors. Now let's run calc 2.com. Okay. Now you see here it says enter a number. We're going to enter in 4. Okay. Now if you press enter, it's just going to screw up. So it's going to take our first number input, okay, and then take our second number input and see equal us out something. Enter number 1, 2, 6. Alright, that's not working out too good. Let's edit calc 2.asm. It seems that we got stuck somewhere. Let's see, we moved this over here. That executed that. That executed that. That's our enter message. That is our this message. Combine them. Move the numbers away. Blah 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 blah. And that's that. Add this here. Move. Oh. What we never did was we never moved the number back to our screen. Okay. That's kind of what we want to do. Adds and numbers, adds and numbers, and right here, right under here, let's then say something like move into our AH register 02, which would be a byte, a character. Move into our DL register. Move into our DL register our values, which was stored in our CL register. Okay. Okay. And that should actually move to screen our string or our bytes. Okay. Okay. So now let's debug that again. Debug calc2, no errors, and we'll say calc clear calc2.com. Okay, enter a number. Let's say 1. 1 and 1, or 1 and 3. Okay, and there's 4. Okay, I'll do it again. We'll say 5 and 4 is 9. Okay, cool. 1 and 1 equals 2. Okay, cool. You can see this is adding. This is adding numbers here. Okay. Now what happens if we type in something like 7 and 7? See, we get a funky greater than sign. Or let's say if we add 8 and 8, we get an at symbol. Okay. Let's do 9 and 4. We get an equal sign. Okay. And what basically is it's taken the values of 9 and 4, alright, which is 13 basically, okay, and it's not giving them out in an ASCII number range or in a hex value number range, but it's giving them out in an ASCII number range. Well, these numbers here, if you look, these things here are below 20, okay, or shooting out values, these ASCII, these funky ASCII characters, okay. Now if I can minimize this, move this over here, and I'll pull up the chart again so we can see what I'm talking about. Of course, because nothing is where it's supposed to be. Actually, it is where it's supposed to be. I'm not where I'm supposed to be. Let's go here. Look at our chart again. Conversion. Hope you guys can see this. But we will see all these unprintable characters down here. They all are like below 20. And so is everything all the way up to our number range. Our number range starts at 30. So anything below 30 is going to be an issue. Okay? Like when we type it in, our hex values, we stripped off our hex values, okay? We stripped off our hex values, so if a number 13 was to come out, this is pretty much where it's at, okay? That's not going to help us out too much, alright? So what we can do is we can add these numbers, and later on, obviously in order for me to have a correct calculator, I'm going to have to change this, but but for later, that'll be later on. But I want to show you what happens basically when you even do add things throughout the debugger. Let's say edit calc2.asm. Okay, we need to set some bounds in here. We need to set some restrictions in here, and actually to what it can read. Okay, and where we can do those restrictions, we can set them up right under here. But let's throw in a couple compare statements, okay? And what we'll do is, let's say something like, get over. Let's do something like compare the CL register with, let's say 39, okay? Okay, and this is going to compare it with the number 9. If it's bigger than the number 9, okay, if it's bigger than the number 9, we're going to jump to a message, okay? So say jump if it's greater than number 9. Let's jump out to 140, okay? Let's go down here real quick, and we'll make some room, and we'll say assemble at address 140, define bytes. Remember we said if it's bigger, we want to say num to large. LG is going to be large. Okay? Okay. Remember that's standard out, so that'll be a 24. Okay? Now, if it's not bigger than 140, what we want to do is we want to sort of compare again. Okay? Compare CL with 30. Okay? And if it's less than 30 to 170. Okay? We don't want to say less than or equal to, because if our number happens to be 0, we don't want to start saying your number's too small. Okay? Okay. So let's go down here and we'll set up another string byte at 170, and we will say define bytes num to small. Okay? And throw in our $ terminator. Okay, that's that. Okay, so now we gave these places addresses and whatnot like that. Now we have to actually give them move functions into our processor so we can call them pretty much. Okay? Okay. So let's do that, and we can do that right from down here. And we were going to say something like, I don't know. Actually, I'm going to set up assembler at 1. This here is a blooper. These areas are bloopers here, and I'll change them in a second. Let's move these around and see if I can do this with this funky thing. If you highlight this, you can highlight this and hit Control X and it'll take it away. Okay? Now, I would like to put that down here and hit Control V, and there you go. Okay? Same thing with like any of our other red stuffs. We can do that. Okay? What? Change these string addresses to this. Okay? And Control X. Let's smudge this up a little bit, and let's put this underneath of here. Control V. Okay, and let's change this address to something like 240. Okay, because basically, these are the string addresses of where we want to go, but not actually what we want to do anything there. Okay, what we want to do, we're going to move up into here. Okay, so let's say assemble. Remember where we were. We were at our first issue is here, which is our jump greater than. Okay, so we want to move to our assembler at 140. Okay, and we want to say move into AH register, a string, and move into our DX register, the location of that string. Remember, our location of our jump greater than, number 2 large, was at 220. Okay, so then we would say 220 int 21 int 20 to exit the program. Okay, and now we can say too, let's move at let's assemble at our address of 170, move into the AH register string, and move into our DX register, location of the string, which happens to be our less than too small is at 240. Okay, okay, and say int 21 int 20. Okay, I think that looks okay. Let's hit Control Alt. We'll exit that. Yes, I want to save it. Let's debug it again and see what happens. Uh-oh, stuck. Stuck. Say debug calc 2.asm. Okay, no errors, no errors. Now let's run calc 2.as.com. Okay, now it says enter a number. I want to enter in 1 and 1. I get 2. Enter a number again. Let's say 1 and 9. Okay, there you go. There's our error message. Okay, let's enter it again. 8 and 3. Okay. Okay, error message right here. Number too large. Okay. And let's run it, and let's say 3 and 5. We get 8. Let's say 2 and 2 is 4. Let's say 9 and 8. Number too large. Okay. Now what happens if we hit in something like 3 and then enter? Number's too small. Okay. Okay. Because it took 3 and then you entered it, and it didn't add 0, but it added, I think, maybe the enter key? I don't know. 3, and let's say P. Oh, okay, let's see. 7, I. Number too large. Okay. Okay, that makes sense. Because of the hexadecimal format. The hexadecimal representation of I is, I don't know what it is. It's got to be up in the 60s, maybe 70s. But it's not. It's something that's bigger than 10. Okay? Okay. So, that's how you do a calculator that only counts to 10. And when I get time and figure out more about what to do, I will help you guys make something that counts bigger than that. Okay? But that's just basically showing you how you can add stuff, and how the assembly calculator just kind of works. We can dump that to, let's see, T, or that's trace by trace. I'm gonna say dump it, and unassemble it. Let's unassemble it, and let's do something like T, step execution. See, moved in our string. That was our string. Okay. It's not really much to talk about here. We already went over this stuff. But, you know, remember your T. You can watch your step-by-step execution of what's going on through here. Okay? Alright, so, hope you guys enjoyed this one. And assembly is fun. Remember to watch your, I have a problem with versions in assembly. And this will work. But, like yeah, you guys know what I'm saying, alright? I already talked about it at the beginning. So, that's that. Let's say sudo su. I'm gonna go back to watching Avi now. PSOX. Kill 1085. You guys have a great day.